So hello guys and welcome back. Today we will continue with our relevant JEE Advanced question series. And so before starting on, if you are new to my channel, just a disclaimer, these questions are not made by me. They have been made by the Maths Explorers group. And I have attached their Telegram channel link in the description as well. If you want to go and check out their questions, you can do. So basically guys, this will be the first question actually which we are going to solve. But before beginning, just a few words that I was actually planning to do something new. That is, I wanted to bring in some questions that I have prepared myself. So if you like, I will bring a trial video on that soon. And if you guys, okay, I will discuss that in that video itself. Just drop down your reactions on that video. Like it's coming maybe after this. Let's see if you like those questions. I have made something, okay. Like this is not this one. It will come in a separate video. Some questions that I have made myself, okay. So anyways guys, this will be the first question for today, an integration question, really interesting. You can try this question out yourself for a few seconds while by pausing the video. I will also wait for a few seconds and then start off with the solving. Okay guys, I guess now it's time for us to solve this. So basically let's look at the question once. So there is one expression alpha which is given to be equal to e by root e into e power 1 by 3 by e power 1 by 4, like that. This is a very standard expression actually, we will see. And I is equal to minus 4 to 0, this thing, okay. So what I am actually doing is, this is I equal to integral of this. I am taking this particular part, like I am writing this before only, okay, so that we have no confusion. I am taking this to be some p. This expression, this complete expression, I am taking it to be p. So actually p is, you can observe, it is of the form of modulus of f of x whole divided by r f of x, where this f of x is actually given to be 4 box of x whole cube, and this is whole divided by your alpha x minus of box of x, okay. This is some sort of like the overview of the question. So now I guess we can proceed. First thing is, actually we need to calculate alpha, otherwise we can't proceed. So let's do that. I will change the page. So for calculating alpha, actually if we want to calculate our alpha, if we like manipulate or bring the powers, it's written in fractions, right? If we bring it to a more like stable form, this will be e power 1 and denominator was e power root e, so e power minus half. After that you will have e power 1 by 3. After that you will have e power of minus 1 by 4, and this goes on till infinity. Basically this thing is nothing but e power of 1 minus half plus 1 by 3 minus of 1 by 4, and this goes on till infinity. Now actually this is a very beautiful thing. If you guys remember that our ln of 1 plus x, or rather not 1 plus x, I guess this will be, okay, it was 1 plus x only. This thing is actually equal to 1 minus x square by 2 plus of x square by 3, x cube by 3, I'm sorry, until infinity, okay. I hope you remember this expression. So this is actually our e power of ln of 1 plus, in place of x we have put 1 right here, so 1 plus 1, so e power ln 2 will be 2, which means alpha is actually equal to 2. So this was pretty simple, but now we have to evaluate this integral, and for that actually if you observe, this integral is like sort of, let me check once. There is, if you actually look at the question, there is box x in the numerator and denominator, and box x actually complicates things a lot, because minus 4 to 0 and box x, this would mean that there would be a lot of intervals actually, like I don't know how many, we still have to evaluate. So there would be some intervals on which actually box of x will divide. So for that we need to evaluate in how many intervals we have to divide this integral. Like you have done box x questions, right? You will know that. So let's change the page and see what this comes out to be. Okay, so let's elaborate things a bit. Say if our like minus 4 to 0 is our given limit, right? So let's take it to all the integer points. If our x is belonging from minus 4 to minus 3, like I hope you understand this is closed and this will be open, then only our box x here will be minus 4, okay. So in that particular case, I am actually here, what we will be talking about is with the expression alpha x minus of box x, or rather 2x minus box x. We will be talking about to what values this thing evaluates, because that will be actually of prime importance. Okay. So actually this particular thing, this modulus x equal to minus 4, for this one, this expression will be 2x plus 4. Similarly, for x belonging to your minus 3 to minus 2, box x will come out to be minus 3. Again, for x belonging to your minus 2 to minus 1, box x will come out to be equal to, this was minus 3 and this will be minus 2. Okay, so I forgot to write that. This thing will be 2x plus 3. And for this one, this will be 2x plus 2. And yet for the final interval, which is minus 1 to 0, I'm directly writing the expression. This will be 2x plus 1. These are the expressions we got. Okay. Now actually there is an observation here. Like after this observation, things will be pretty simple. If r, I'm writing this in sort of words. If r alpha x minus of box x, okay, this thing is positive, greater than 0. In that case, you will observe that f of x, it becomes less than 0 and I is equal to minus 1. I will show you why. Okay. You might be having questions why. First, let me write the result. After that, I am showing you why. And if we reverse the sign, like if alpha x minus of box x, this thing becomes less than 0, then f of x, this thing will become greater than 0 and I will be equal to 1. Okay, now let's see how this is coming. So say if I take x belonging to minus 4, now what I am doing is basically like minus 4 to I am taking minus 2. Okay, there's a reason behind that. Basically because this thing is our 2x minus box x, right? 2x minus box x. So if we actually put these values we found here equal to 0, this thing, if we put like this thing, okay, this and this, if we put them to be equal to 0 to find critical points, what you will actually get is, from here you will get x equal to minus 2, from here you will get x equal to minus 3 by 2. So minus 3 by 2 we are not sort of accepting, and x equal to minus 1. Okay, and another one will be x equal to minus half. So minus 4, minus 3 by 2, and after that minus 1. So I guess minus 4 to minus 2 can be one interval, and like I will write this down for your convenience. This thing was your minus 2, and before that we have the limit, like this thing is our minus 4. Okay, so this and this we take in one interval. Minus 4 first we will have from the limit itself. After that we had a minus 2. Like actually you guys know, right, how we evaluate the box function type of limits. I am doing something similar. Okay, I'm not writing the integral part right now. I am just doing it manually to see how many limits are, how many, I should say, splits we are going to do in the main integral. So minus 4 was the limit. After that we have minus 2. After that we have minus 3 by 2. Finally minus 1 and minus half. So I guess minus 4 to minus 2 can be the first interval, and after that minus 2 to minus half can be actually a second interval, because these two are coming in between. And minus 2 to minus half, I guess that will be actually good. Why? Because the last interval that we are going to take, it will be minus half to 0. Okay, now you will have an obvious question, like if I take minus 4 to minus 2, why didn't I take minus 3 by 2 to minus half? We are actually like trying to restrict to the extremes. Okay, if you don't know what restrict to the extremes means, basically minus 4 to minus 2 will be one interval. Now minus 1, okay, like I am trying to take this such that because minus 2, this interval ended in minus 2. If you know the integration, how we do it with box functions, minus 2 has to begin here. Like if this is the minus 4 and minus 2 are the limits of the first integral, minus 2 has to be the lower limit of the second integral. Because minus 2 was the upper limit of the earlier integral, so minus 2 has to be the lower limit of the second integral. Something like that. So minus 2 to minus half, we can take it as 1. And finally, your minus half to 0. Like these sort of questions have come in JEE Advanced a lot, okay, where you have to actually like the whole sum actually depends on this particular breaking. Actually, the whole sum, whatever answer you are getting, that plus 4 marks you are going to get from that integer type question, everything actually depends on this breaking. If you do this breaking properly, your sum is done. Because once this breaking is done, you will just put the conditions, take the values, and unless you are not that unlucky that you do a mistake in calculation, your answer will be fully correct. Okay. So I guess this will be roughly the breaking. Now we will still see in putting these conditions if we can shorten this interval further. Okay. So let's see. I will change the page and manipulate. So if we actually see in minus 4 to minus 2, what we will find here is your 2x minus of box x. This comes out to be less than 0. Alpha x, alpha was 2. So 2x minus box x, it comes out to be less than 0. Now why? Because like minus 4 to minus 2 in between box value can be anything. Say we take minus 3. Okay. So minus 3 times 2 is minus 6. And minus of minus 3 will be plus 3. So that is a negative value. You can like take any value in between. This will always come out to be negative. So in that case, actually our f of x will become greater than 0. Because of that, like you remember in the question, right, that modulus f of x by f of x was present. So for that, actually this thing becomes greater than 0. And your, okay, I actually wrote I, right? Okay, change, just a minute guys. I actually wrote I here, change this to p. That is why I was using a different letter. That expression is p. Okay, this will be p. P will be actually equal to, p was that f of x by mod x I took, sorry, mod of f of x by f of x I took at the beginning of the question. So this thing actually comes out to be your 1. I'm sorry, minus 1. Okay. Okay. So, okay guys, f of x greater than 0, right? Okay, this will be plus 1. I'm sorry, I messed up. So for this thing which is less than 0, p equal to plus 1. Now let's move on to this interval, which is our minus 2 to minus half. Now actually, if you see here also, if you in this interval also, if we check, what you will observe is the conditions are same. 2x minus box x is once again less than 0. I guess, yeah. If you like, you can test for any value, this will always come out to be less than 0. Like say, what should I take? I should say take minus 1. So minus 2 plus 1 will be minus 1, which is less than 0. So again, f of x is greater than 0, which means your p is again equal to plus 1. So actually what will happen is, we had 3 intervals, right? Actually, we can merge these 2 intervals into one. From this condition, we can take minus 4 to minus half directly. We don't need to like take 2 different intervals for this. I hope you can understand, right? Like if the behavior of the function sign behavior is same, we can actually merge the 2 intervals. I hope this was understandable. Now actually, if we notice in the last interval, this is where the sign change will actually come. Minus half to 0. Here actually you will observe that, for example, if we say take, what should I take? Minus 0.5 to 0, right? Like you can actually take any value. Say, okay guys, this thing will actually be a simple bracket. Yeah. So you can actually take any value minus 0.5 to 0. Like I'm not calculating this, okay? Pretty simple. You can take any value actually, and this thing will be coming out to be greater than 0. Positive. So I guess if this thing is positive, then your f of x, the sign will be negative. So in that particular case, p will come out to be minus 1. So actually this and this value is equal and this value is a bit different. So now we are now in a very comfortable position to finally evaluate our integral. Okay. So let's do that. So our final integral, which is I, this will be equal to, I am merging the first two, I mean your intervals, which we found the values to be equal to. So this will be directly minus 4 to minus half and 1 dx plus of integral minus half to 0 minus 1 dx. So bit of calculation we have to do. This thing is, I guess, coming out to be minus half, like x and the limits. So minus half of minus 4, minus half minus 4, minus this will be 0 minus of minus half. So let's evaluate this. I guess this will be plus 4 and minus half and another minus half, plus minus. So minus half times 2, which is minus 1. So your final answer for this question will be 3. I hope you could understand this question. This was a good question. Okay, like this type of breaking like box function is actually a very famous concept. Multiple times asked in JEE Advanced. You can check the PYQs as well. Very relevant. Okay, and this was a good question also. So that's it for the first question, guys. Let's move on to the next question. So here's the second question, guys, and this question is a very, very good question. I really liked. Like this question doesn't have some like very real sort of, what should I say? Not very much amount of manipulation, but the concept used in this question is very, very good. Okay, like prime JEE Advanced type, you can say. People do tend to make mistakes in such questions because like if you want to be a universal aspirant, then you have to be good in solving, good in calculations, good in concepts, and good in handling unexpected questions. So this is actually not unexpected sort of, but yeah, this question is a very good question. Okay, so you can try it out, guys. I will wait for a few seconds and then go on into the solving. Okay, guys, I guess now it's time for us to solve this. So f of x is given out to be this. So let's define it. Like let's write the question first. F of x is given to be your limit n tends to infinity. Cosine power n 1 by n power x for x greater than 0. And let's take our yn of x. Let's define a function yn of x. Actually, we are taking this part separately. Let's define yn of x as to be equal to cosine power of n 1 by n power x. Okay. Now, actually, I will be using some little amount of approximation here. Okay, like approximation is actually a topic which, like, you might be wondering what is difficult in approximation, but approximation actually has a huge amount of stuff in higher mathematics. Okay, it's not included in your syllabus. The amount of approximations that you have seen is only when you do limit sums using L'Hopital's rule. You put cosine x, sine x, those expansions. That is some sort of approximation that you have seen, and some sort you have seen in binomial as well. The rest of it you don't actually know what approximations are. It is a huge deal. Okay, like higher mathematics contains a very huge amount of approximations. So it is nothing of that sort. What I will do is I will actually approximate our cosine n power 1 by nx to two terms. Okay, one constant term and one power of x using the expansion of cosine x. Like if you know cosine theta, I will just write this for your reference. Cosine theta is our 1 minus theta square by 2 factorial. And this goes on, but we are not taking those terms. I will put the approximation sign. We are approximating this to be 1 minus theta square by 2 factorial only. Okay. So now, like we have to talk about the argument theta, which is 1 by n power x here. And also if we take cosine power n theta, this will be whole power n. Okay. So let's talk about the argument. So if 1 by n power x, this thing actually tends to 0, n will actually tend to plus infinity. I hope this is clear. Why? Because it's defined x is greater than 0. It's defined in the question. So I will change the page, just a minute. So actually what we can do is we can write our cosine power n 1 by n power x as your approximated 1 minus of 1 by 2 factorial is 2, right? So 2n power 2x because theta square was there and whole power n. This is actually the form sort of we need to work with. So what you can do is like you can take x, I mean, if you actually, I should show this. If you observe from the question, let me show it. Here actually a is defined from 0 to infinity. Okay, like it is perfectly positive. So now what I am actually going to do is, for your convenience, this is actually a very standard limit. Okay, Like not something that you have learned in your textbooks, but this is a very common sum. So I am writing it down. This will make our job easier for understanding. If we take limit n tends to infinity, 1 minus 1 by n power a whole power n. Okay. I am defining this piecewise. First, we are taking this is a, okay, like this a and the a you see here. I will show it just a minute. The a you see here are actually not related. This is something different. Okay. So this is our 1 minus 1 by n powered a, and now if we actually see a greater than 1, a less than 1, and a equal to 1. If we see these intervals at a greater than 1, this thing actually comes out to be 1. At a less than 1, this thing comes out to be 0. And at a equal to 1, this will be 1 minus 1 by n whole powered n, which is a very special 1 powered infinity form. Okay. So if you actually evaluate that, I'm not going into that. It's pretty simple. This is actually coming out to be e power minus 1. Okay. This part you could understood, like you can understand 1 power infinity, and a less than 1 will actually make this part very small. So it will be like not small. A less than 1 will actually make this, say, I should take an example, maybe n powered of 0.00 something. Okay. So n powered of 0.00 something, and limit n is tending to infinity. So actually it will become 1 minus 1, I guess, power 1 minus 1 as equal to 0. And for a greater than 1, this is already becoming too small, like the denominator is becoming too big, so the fraction is becoming too small, so that in that regard this will be 1. Okay, like this is a sum that many of you have done, I guess. Very common sum, and actually this is going to help us a lot. So if we actually substitute a equals to twice x, then we will see that our 1 minus of 1 by 2n power 2x whole power n, the function we have, this function actually behaves very similar, okay, to this, very similarly. So if we now, like we have put a as greater than 1, so if we substitute, I will again define this in a new version piecewise, 2n power 2x whole power n. If we define this, then 2x greater than 1, I can write it as x greater than half. 2x equal to 1, I can write it as x equal to half. And your 2x less than 1, I can write it as x less than half. Okay. And here the values will be obviously same. This will be 1, this will be e power minus 1, and this will be 0. Okay. So actually the question was asking us that at which point this thing is discontinuous. So you can see our answer has already come. It's half. And why it's half, I will explain that further. Basically, if you try to graph this roughly, if you try to graph this, 0 is somewhere here, this will be somewhere e power minus 1, and here will be 1. Actually, x, okay, it's not actually e power minus 1, this is half. And e power minus 1 will be somewhere, I guess, here. And also one output value is coming to 1, so we should write that also. So actually, if you see at x less than half, I will use a different color, guys, just a minute. Yeah, if you actually see x less than half, the value is continuously 0. But, there's a but. Please note, this, I am drawing this, so please see my drawing carefully. There will be an open circle here, which means there is a discontinuity, okay. At x equal to half, this is e power of minus, okay, I wrote this e power minus half or what? This is e power minus 1. I'm sorry, e power minus 1. So at e power minus 1, this is equal to x equal to half. Okay. And again, if we see for x greater than half, then it is equal to 1. So we can again put an empty circle here and begin this. So this will be actually roughly your curve. Okay. Like if you have learned your discontinuities very, very well, you will know that there is a jump type discontinuity. Jump type discontinuity basically means that our like the curve, you can understand from this example only, the curve is continuing somewhere, it jumps off to a different value, and like this particular part remains empty. Okay, like in simple words, if you want to understand, if the curve breaks at any point, it means discontinuity, and here the curve has broken. And if you want to know the specific name, this is actually called a jump type discontinuity. Okay, so our final answer, I guess we had to find out the point where it is discontinuous. So final answer will be x equal to 0.5. And you can ask me like, why didn't I use limit n tends to infinity and all? It's already included. Okay, I forgot to write actually. You can include that limit n tends to infinity here also. Okay, like from this only we derived this part. So guys, I hope this question was clear. This was a good question. Okay, like you can actually, if you, I did this because I took this expression as a standard form because it might be easier for you to understand. But even if you don't use this expression, you can get it from here also. Like one thing should obviously strike your mind, that when I am doing 1 minus theta square by 2 factorial, I can write it here. When I am doing that 1 minus theta square by 2 factorial, I am approximating, right? So if I actually put, like you guys know, if we cosine 1 is actually a very small value. So in place of theta, if we put 1, this actually comes out to be half. That can also be one reasoning, because the x was, I guess, greater than 0. And our a was also defined from 0 to infinity. So you should start from a value which is very close to 0. Like it can't be exactly 0 at any cost, but it will be a value very, very close to 0. Okay, greater than 0 but very, very close to 0. So from here also you can actually have an understanding that this will be maybe half. Okay, but that is sort of a clickbait. The best method is, if you can evaluate this particular limit, you will get these values only. That's not a problem, but you will immediately understand that x equal to half is our thing. That's why that approximation was really important. Okay, otherwise only defining cosine wouldn't have given you the answer. And here's the graph also. I hope you could understand this. So that's it for today, guys. I hope you can understand these two questions. And if you have enjoyed my content, please do like, share, and subscribe. And any recommendations, any doubts, always feel free to ask me in the comment section. And that's it for today, guys. Thanks for watching.